Hello world, thank you for hosting us here in this amazing conference. We're going to talk about contra-driven development in AsyncAPI, tools and procedures, something that we use in our day-to-day in order to create our amazing software. But first of all, let me introduce myself. Who I am? My name is José García Maciñeiras. I am principal software engineer here at Sngular, coordinated by Sngular for the moment, with more than 16 years in this mess, fighting in different places and in different trenches. Nowadays, I am the leader of the open source initiative, the OSS, also the Special Service Office here in Sngular. I am the father of Calogene, the multi-API generator and the multi-API contract converter. These three projects are one of the main ones that we deliver to the community, so we can share with you our amazing coding styles and our good to do the things. Okay. I also are the master slave for my two cats, Kiko and Kitiara. What can you expect from this conference? Just another way to do the same, another tool to do the same thing you are doing every day, another way of thinking, another path to try maybe, another thing to discover, or not maybe? So first of all, let me tell you a story. When I was a younger kid, I was a fat, hairy young fella. And as usual, the people started call me names. I was called gorilla, monkey, chin, blah, 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 blah. So you have two choices regarding to this point. Fight them or embrace them. The first thing I do was fighting them. So was amassing fights, kicking and kicking. But at the end, I embrace the gorilla thing. So let me introduce one of my friends. Once upon a time, there was a mono called Lito. Monolito was in charge of his pack. So he feed the pack, he defend the pack from others, he communicated with all other packs, and he was doing all monkey mono stuff. The time passed. Lito was a successful mono. His pack grew more and more, with more females, more monkeys, more chimps. He was a really nice and big pack. Other packs looking as a successful mono, so they wanted to make business with him. He was busy and he was happy. The business expanded. Everyone wanted to work with Monolito, requesting food, requesting protection, requesting all monkeys, different apes stuff, and different apes start contacting to him to work together. So he faced the problems. There are different names for banana, there are different names for tree, there are different names for whatever thing the apes do every day. Other types of food were requested, not only bananas, just only nuts or different fruits, and more stuff they were requested. So what he made? Lito has a problem, but Lito was a smart gorilla. So he started thinking and thinking and thinking, and he got a bit idea. He defined a way to talk to each other, so he can communicate with different apes, with different monkeys. He structured a message system in order to communicate the data or the message between all of them, something that was easy to read and easy to understand to all the apes. Mono sketched what he called the Apes Petitioning Interface, or the API, defined it as an structured way to request bananas and other stuff from me and my pack. Monolito was happy. Every ape in the jungle was starting to use his API in order to request information and send information. Apes from other jungles started to communicate with them, so he expanded his business to other jungles. He sent his small apes there so he can start working in a huge corporation. We are really happy and really rich for now. Monolito aged, and he needed more hands to help him. So he started to delegate all his knowledge and expertise in different small apes, like a micro apes that start working in different jungles. What can go wrong? They have the API here, so he can exchange information, exchange data, may request it. Happened that other species appear on the stage. and he wanted to talk with him and cooperate and increase the business and share information between each other. So he needs to improve the API. He needs to control the transactions to avoid the API to be tweaked and broken. So the information keep stable between all the transactions. So Mono created a way to control transactions or contracts, defined as framework to guarantee the correctness of the message exchange through the API. Monolito and their colleagues were happy, really, really happy, because they found a way that keep the API stable, that the information we share between all the different apes and different groups and different packs doesn't matter which was the language, they will understand each other. Okay, let's gonna talk about contract testing. What's meaning contract testing? What is contract testing? There are different definitions based on where you make these testings. You can make the testing for the consumer part, you can make the testing for the producer part. There are different approaches about that. Contract-driven development try to join both approaches in one. So taking the common points, that is, you have two actors, consumer and producer, is based on schemas, so you need to define what's the structure of the data that you are sharing between the different actors. There are some kind of field bindings, so you have defined your field with some limitation, with some constraints. Let's say a part of the type is string, integer, float, decimal. You can specify some regex, you can specify some limits, top limit or lower limit. And the main important thing is this is an agreement of minimum. So what you are guaranteed is that you at least will send the specific data, defined data that is in the contract. You can send more of that, there is no problem, but you cannot send less than what is specific in the contract. Excuse me. Right now, there are two big players in this war. Pact, with the Pact broker, and Spring Cloud Contracts, that is an open source solution from Spring. Pact is a pay solution, so you pay for to have your broker and you use the system. Spring Cloud Contracts is open source, so you need to install it and do it by yourself. This one is my favorite one. So we are going to talk about it. So, as I said before, contract testing guarantees the correctness of the message, meaning that I am maybe a bit hard on it, that you guarantee that the message is sent and received as has been defined in the API. So you will receive the fields with this type, and you will add some kind of validation for that. Let's say that you are sending a string, you will not send a number. So the tests that are generated are verifying that it is going to happen. It allows us to test both actors. So you will have validation for producer and test for the producer part, generate the stats for the testing, and also validate the consumer part. So it tests almost every part of this exchange. One strong point of the contract-driven development is that they give you independence between the teams to develop. So once you have defined your API, you generate the contracts. These contracts are shared between all the teams. So producer teams, provider teams will have a mock request that will request the data, and it will validate the response. In this case, you will receive a specific event, and we validate the event that is produced by the provider. Regarding the consumer, it will receive event produced for a mock. So what does that mean? That my consumer will be listening to a queue or a channel and will receive a data that more or less is defined in this contract, so it can test his own business logic. So that's the main point and the strong point of the contract. Once it's defined and shared between the teams, they can start working independent without no problem, meaning that when they reach production, maybe it's not 100% guarantee, but let's say it's 90-95%, all the communication will work quite well. Contracts are integrated in the build part of the project, so in theory, because you know that something can happen always. All the code will be validated in the build stage, so nothing will reach to production if all the things are done properly. Okay. So what is a contract? Well, we have here a sample about a contract, how a contract is. As you can see, there are two different sections, the input section and the output section. The input is made for the provider to receive the message or the consumer that is receiving the message, and the output is made for the producer. So the producer will send the message to that channel defined in the send to part, and the body will have those fields. You can see here that there is some data. This data will be used to create the stubs for the consumer. So the consumer will receive a message with name Adama, the account number 0002, and the update date 2022-10-21 at 4:30 a.m. in the morning. What happened with the input part? The input part will mean that the provider will receive a message in this channel, and this message will have that body, an amount of 2.5136, blah, blah, blah. The last update is a character. I don't care about that because there is no boundary about that. The name will be Adama, IDs, account number. All this data is created or defined based on what is specified in the contract. So as you can see, this kind is made in YAML language, so it's kind of readable. We can also define it in Groovy, that is more or less as well as readable, or in Java. Okay, this is maybe not a readable language, but it's not so complicated, right? About how we can trigger those tests. There are three different ways so I can trigger a test into a contract testing environment. So I can have a trigger function. I will see later the samples in the real code, okay? So I can define a function that will produce an output message. So the contract framework will receive this message and will validate it. We can produce a message based on an input. So the system will receive an input, define it in the app part of this sample. The business logic will do all the magic and will produce an output message that should match the one that is specified in the output message. Or I can receive an input message without no output. Let's see that we are creating a service that is a sync, so we only receive message. So we only have the input part, meaning that this message will be received by the system, and we should provide a function in order to make the validation. Okay? So in a Spring Cloud contract, there is no attachment to a specific product, meaning that I can keep the contracts wherever you want. If we are talking about the path system, you need to have the contract in the path broker, so you pay for it. But in a Spring Cloud, you have it in your Git, you can have it in a file system, you can have it in your local folder or whatever, so there is nothing that you need to pay for. You should provide it, okay, but I mean, it's free, okay, happy news. And also it's a polyglot, support different language, so I can have a team in the backend working in Java, and I can have a team for the frontend working in Node.js for whatever reason I have. So the tests will be defined and created for both people. They can have another team working in Python that will be also receiving their own testing. So it's open to whatever language, right? But okay, this conference is about AsyncAPI and contract, how these two concepts, how these two worlds can match. Well, AsyncAPI is, as an API petition interface, will define how the communication will take between different apes. Contract will provide the necessary tools to ensure the communication is done effectively. So how it can be done? How I can use the power of those tools, of those specifications, for guarantee that my messages are provided and are working and my system is perfect? Well, let's go to introduce another thing, the API first paradigm. meaning that you should define first the API, then we should create the contract, and then we start working on building our solutions. That can be a bit controversial, right? Because we will have a working API defined by the ape petition interface. We will have a framework for testing the service, but we should keep updated different set of files, ones that will define the API and ones for define the contract. And remember, I said you define the contract in YAML, in Ruby, or in Java files. But the AsyncAPI is made in JSON or in YAML. So it's different, it's more work for the teams in order to handle this. So is there any solutions? It's complicated, we face that. Having the AsyncAPI files in one repository and then the content in another repository. We were updating the AsyncAPI and someone forgot to update the contract, so the tests start failing, the product start not be deploying, so it was like a really headache. So we found a solution. We create the multi-API tools. Woohoo! Fantastic. So what we have here, we create a Spring Cloud Stream multi-API plugin in Maven and in Gradle that generates code based on the AsyncAPI, so we can generate our own code, Java code for the moment, producer and consumer, and we create a Spring Cloud Contract multi-API converter. So we can convert APIs based on OpenAPI and AsyncAPI into real contracts. So at least we will have a set of contracts based on those APIs from scratch without nothing to do, just only configure the system for that. So the ACI multi-API converter can work without the multi-API generator. So let's focus in this component. We parse the AsyncAPI file. We create the contract based on the defined operations. We create the stat based on the sample provided from the AsyncAPI file, or in case you don't have defined any examples, because you are in the early stage of the definition, we will generate random data matching this definition. Ideally, you should put examples on your files in order for documenting. Okay, remember that. But sometimes it doesn't happen, that you don't have time, or there is not enough definition, but your teams need to be working quite soon because the deadline is almost there. So you define the AsyncAPI and keep working. So in order to avoid you waiting we generate some random database on. Okay, you want to see how it's working? Let's gonna do a demo, and we'll see later how it works. Okay, then let's gonna do a small demo to see how our tools is working. So we're gonna show you how the apes can create their own business and conquer the world. So now I am moving to the presentation thing. Here we are. So as you can see here, we have an AsyncAPI version 2.3.0. Have our info about the banana petition service. Okay, this is our API. And here we have a couple of channels. The account channel, so we will have our ape accounts that will send through different systems. So we have our petition, so here we will receive our petitions, okay? And here we will receive the new accounts, so this will be an ape account. So this channel will gonna publish all the information about the account that has been created and has been updated. We receive the petition for bananas in this channel, so we are subscribed here, and our account system or user system or whatever system that apes have in place, they will send the new account using the same ape YAML here. So check it that we are referring a new file that is here in this place. So let's gonna see what is inside. So here we have an ape account event. This is an object with those properties. It's normal AsyncAPI file. Here we have a pattern that we use later on, but you can see that here we are defining something interesting, okay? In this one, we have the banana petition. So here we have another object. It's a normal object. So we have an example. Okay, as I told you before, you should have an example every time. We define floats for the amount. We define the petition type, that is car, cash, credit, debit. We can use also PayPal for the apes. They are very modern in the last times, okay? And nothing else here. So yes, my POM file, we have here two things. First of all is our Maven plugin for generate the code. So this is the group ID artifact. This is the standard configuration, and here we can specify the spec files. Sorry. So here we are specifying the file for our async API. We are choosing the IDs of the operation that we will consume, and we define the ID of the operation that will create an string bridge, meaning that we will not follow what is specified in the event API. By default, we will say if you have a publish here, we will create a producer. If you have a subscriber here, we will create a consumer. But we allow, in case you are using this API in the other side in the other part of the communication, to specify to produce in the subscribe operation. So with only one file, we can cover both sides of the saga or different sagas. We configure here the API package and the model package, so all the classes will be built in this path. The model will be here in this path, and the same happens with the string bridge. But what about the contracts? The contracts here, we are using Spring Cloud contracts, so our converter is set as a dependency, so automatically we will get the file defined here in this folder, okay? And we will create all the tests necessary for that. The package that will be used for create the testing classes is specifying here, okay? One thing that we need to create is this content verifier base. So this class will be used for create and for running the test in the producer part. For the consumer is another word, is different class. I don't have it right now, but you can see how it works. We can see a producer, and we can see the validation for the consumer part. One thing interesting, we will create, let me put it in that way so we can see each other. Okay, so we have here the operation ID, store petition, new account. We'll create this function with this name based on new account plus the validation suffix. So here you can put the code for validate the message that you are receiving in the input. Same happen here. Okay, and this is a comment for later, something that I will need to show you. So here, when the test will be created, it will call this store petition once the data, once an stub is injected into the system for this specific operation ID. In this case, we are testing the producer, so we are producing a message with this specific class, this specific entity. So here, my service will convert it to the message that we will create with the plugin, and will validate that these fields match the schematic that has been defined. So let's show how it works. Let's gonna do the standard Maven install, cross fingers to see if something is broken or not, because this is a live demo-ish. So things are running. We have some warnings here because by default, Spring Cloud is also reading YAML files. So, but we got here some warning that the file will not be able to be processed because it's not a standard Spring Cloud contract file. We are working on it. We still have plenty of things to do, but what I want to show you is these two things. So our generator has created the emitter and the listener. For the Streamlit producer, we have this producer here, and he is waiting for offering this method, so you can have this event and will produce into the account that has been defined here in the channel, as you can see. Excuse me, here. So we already have a code, so can be used to produce messages and inject it into the channel. Excuse me. Regarding the subscriber, we have a subscriber class that configure all the beans for the subscribers, okay? And we offer some interface you need to implement. This interface, what they have is the method defined here for store the petition and for store the new account. Okay, let's gonna close those ones, and so you can see based on the APA that we have defined here, we have the store petition function, the store petition operation ID. We will receive a banana petition event that is defined here in this class. That is here, okay? And it will call the object that you have implemented following this interface. Okay, this interface we can see here only have this method. So here, implementing this interface, you will introduce your logic business into the system. So you will receive an event that has been created as well with our plugin. Okay, so this is JSON. We have here the enum type with the values. We have all the methods, so you can have the builder. The builder is also implemented here. So all the code you need to work with this API is already implemented and offered for us to do. Okay, but what about the contracts? Because something I was telling you that is magic, that is fantastic, that is wonderful. Contracts are generated here in this piece of code. So first of all, that we got is the contract that we created in a YAML form. So this input and output message is a Spring Cloud contract YAML file contract. Sorry for the contract thing. By default, if we don't have a regis or we don't have something to follow, we added a standard string validation for the string that we are adding. If there is a number, like here, we added the regex to validate that this is a proper number. So here we will not receive a word or a letter or something. We just will receive a number. If we are trying to push something different, it will fail. Same here, that here we have a regis for testing the ICO datetime. But how we can ensure that this is working? Well, here we have the contract class is extending the verifier that I showed you before. Let me close here and there. So this account emitter is triggering a message with this payload, okay? So here we have the when part is when triggered this function here. The verifier of the message is receiving in this destination that is also defined in the, let me show you here. we have defined the channel. So we are linking this class to the same channel that has been defined here in the async API. We are converted from this account emitter YAML, and here what we're doing is getting the JSON from this specific response. Okay. Once we have it, what will happen is this message will parse against the regex that we have defined in the account emitter. So here, let me put it one side by side. Here we have it. So this regex that we have defined here will appear in the matched part of the string. So every field that has been created and pushed in this schema will be validated. Same happen with the number, same happen with the string, and also the same happen with the time that we have here in an ACO format, right? So this is regarding the producer part that we have triggered here and called it this test. What happened with these two? As I told you before, when you create a consumer, that's only a consumer without output method, meaning a sync method. So we will create a message and we will put this message into the system. So we create the input message based on the payload with the headers and so. We inject this message into the same channel that has been defined here, okay? Following the contract that has been stipulated in this file here that we can open right here because it's beside us. So why I am doing that? Because this message, this contract function, what it makes is validate that this input message match this specification that we have here. If we have any match in that case, we don't have any match, so it's okay, we are doing. What happened here? Once the message has been sent into the channel, we will call this function here, the store petition validation. The store petition validation is one that I implemented here. So using the verify from Mockito, I will catch up the parameter that call it from this method. We get the value and we make the assertion. So you are asking about these two lines. Well, let's gonna do a break here and go to the code. In the code, we have our listener here. In this case, is the banana listener. So my banana listener is this class that is implemented the store petition that we saw earlier that will receive the banana petition from the channel because this is a bean that you know what is doing. Okay, so here we have the petition process service that will handle all the petitions. So once this method is called, we will save the petition, we will increment the counter, and with some login. So here you will implement your specific business logic, right? The thing is that because we have defined that as a mock bean, this is a mock, so we are capturing the parameter that we are saving. So here we have a mock, we are calling the save method, but here this object that we are creating here is captured by this argument captor here. So once we get it, we can validate and assert all the values and blah, blah, blah. Same happens with the new account validation. That is the next method that we have here, okay? So again, we create the contract. The contract also validate that the message that we created is according to the definition here. It's sent it into the channel. We receive it in our code because we have here a mock. We capture the input. We get the value from that, and we validate that it's not null. Okay, this is not a super complex validation, but this is only for the demo. If we want some complex validation, we just need to open and comment in this code and do some import thing here. And let's see, is this one here as well or not? I think I make a mistake here, yes, because this is the event one. So now it should be something like I think it should be is the banana petition event point petition type. So now we are a square. Okie dokie. So what happens if I run this test here? Because we can run it the straight away from here, so we already have the code and inside the unit code. The IntelliJ starts doing his magic, compiling and so, blah, blah, blah. So we start working, and if we have a run, we can start doing the noises. Okay, all tests are passing, but this one is failing. Why is failing? Because the validation is failing because we are expecting to find 10.45 as float, but we are getting these kind of things. Oh my goodness, why this can happen? Well, we can start discussing later, but this is like a problem with Java regarding how it represents the floats, and so this is a problem that you need to solve. I mean, doing the proper conversion and here, but let's gonna do from something more easy. Let's gonna change here for a 10 because we want here a 10, and in the banana petition we can send here a 10. So if I make another install, I will should get flagging colors. It's compiling, doing the test, and the test is failing. Oh, because the test does 0. You can see that we are really testing what we are expecting and what we are receiving. Now it's complaining because, the dates is something that is always. Okay, what is failing here? The dates. So we have here an apply date null, and here I have a movement date and apply date. So let's gonna go to my validation thingy that is here. So what I can see, if I am receiving a banana petition entity that has this kind of validation field, petition number, but here I don't expect to receive any data. In that case, I am receiving data. So this should be my minimum data to validate because it's the thing I am receiving, but here I don't consider any data. I can edit here some functions to validate the data in case this is random data, or I can come here to the banana petition and there is some example for the data, and blah, blah, blah. There are different solutions, but my point here is I am receiving two fields that is mandatory in the contract, moment data and apply data, and here they are not expecting, so the tests are broken. Let's say that someone is modifying the contract with some real data and adding more field that I need as a producer, or in this case as a consumer, I should receive, but I don't taking care of. My test will grow, so I will notice that something is wrong. I need to implement something like that. Okay, guys, let's gonna move to a new thing I want to show you. Let's say here, another test I have defined. Here I have an account number. The account number now has a pattern that needs to be fulfilled. If you can see here, the account number that I am sending in the meter has an account number DDDD, but someone has came to the API and defined a format, okay? So now everything I generate will match this format here, meaning that my contract here will move from this regex expression, okay, to the new one that is in the file. Okay, so now I should see how these things break when I execute it. So I validated the test. And my account emitter is failing because my expecting actually is DDD and it doesn't match the pattern, 1 or 3 O's and some numbers. So let's gonna replace the field that I am using. So 000023. That should make the thing. I think so. Let's gonna try. Executing the test. Still complaining. Okay. Yes, because I am a bit dumb myself. The 2 is not in the regex expression. So yes, we are sending more or less the same, but we are still not matching the same expression. So here, that you can see, there is not only numbers, it's numbers, but with a specific format. Okay, let's gonna try again to see how the thing is working. I cannot tweak the system. Okay, now it's complaining because I expecting 1, 2, 3. Okay, that's my problem. The problem is the piece of meat between the table, between the chair and the computer. So the expressions say number between 3 and 9, okay, and a 2. Number between 3 and 9 and a 2. Let's gonna try again. Hopefully, I will become smart, maybe, and a smart ape. Flashing colors. Now we are generating a contract, an object that is matching all the specifications that we have here. So as you can see, just in build time, I can verify that the information that I am sending is the one that I am receiving. If you can be able to get your teams talking together, the front end, the back end, or the other microservices, and define the API first, and then we can generate a contract, so you can start working really, really fast instead of waiting because one team doesn't have the producer, other team doesn't have the consumer. So I think we can ensure that the speed of the development will be something improved and really great. So this is for us. This is the demo that we have. So if you have any questions, now is the time to do it. So thank you very much for hosting us. And here I will be waiting for your questions. It's a pleasure to show you our tools. Thank you very much.